Start recording. Okay, welcome everybody. Tonight is the 16th of March. We're here online for Dallas Personal Robotics Group Robot Builders Night Virtual. We're going to do the usual thing which we do, which is go around the table and show projects we've been working on and ask questions and have discussions on things related to robots and whatever else hits our fancy. So with that, I'm going to stop presenting and we'll start off with Chris. And then I'll go, and then we'll just work around the table. Chris, what you got?
Thank you. Okay, so let me make my camera mobile in a second. So last time I spoke a little bit about how I'm experimenting with connecting Arduino and STM32 to my Pi. So I have a little I/O coprocessor. I talked about using just serial link, whether it's actually UART or actual virtual UART over USB, and sort of the success I had there with the STM32. Now, so I spend more time, using the STM32, in this case, as this green pill or black pill, really, as the platform, and I hooked the B&O 85 up to it, an I2C, and I actually ended up wasting a lot of time, and still am, I think, just trying to get that to work for some reason, because somehow there's something funky in the interaction between the B&O and the STM32 on I2C, where I haven't quite gotten to the bottom of it yet, but the B&O seems to just occasionally decide to pull the data line or the clock line low and just keep it there indefinitely and never release it. Yeah. If I remove the B&O from the equation, I have a little OLED on the same bus, and first, I suspected the STM32 as a culprit, but, I have the OLED here, there's a lot of focus, sorry, on the same bus, and then over here, I've got the B&O, the little blackboard, and on the same bus. The moment I just hold the B&O in reset, everything's fine. When I power up or when I reset the STM, the OLED initializes, it puts like ready on the screen or something. The moment I let the B&O participate, I have I don't know what the success rate is of coming out of reset properly or power up, but it's at best 50%, and I can put the reset button here right now. Okay, now we got lucky. All right, you saw a little ready flash by maybe, and you can't see the number here, but I'm just displaying the angle, my heading on the OLED. But if I keep hitting reset here, I think I'm having a little more luck now, because what I actually did, now I'm explicitly resetting the B&O, using its reset input rather than just leaving that reset input on the B&O so that it's not in reset. I'm now explicitly resetting the B&O, taking it out of reset, and then start talking to it. That seems to help. I'm still not at 100%, and I don't think I have a trace here up on the screen. This trace actually was a successful one, so I don't have an error case here on the screen right now. But it's only today that I got my hands on my little 8-channel logic analyzer. I didn't have it for the last couple of days, and so I'm looking at that, and again I could see that occasionally the clock and/or data lines are just kept low. Now, the B&O is a very slow device. I mean, you can see, and you can't read the numbers, I'm sure, but right now that blue stuff in the middle is about 800 microseconds, and that's clock stretching in action. Okay, that's the B&O holding the clock line low, until it's ready to give data. And I mean, the STM is supposed to deal with that, and it seems like it does. And initially I thought, okay, I knew that the B&O is a slow I2C device, and so initially I thought, okay, maybe the STM isn't configured correctly, maybe the clock stretching isn't enabled or something, but I don't think that's the case, because the STM is dealing with it just fine. Like I just said, it sometimes takes 800 microseconds for the B&O to acknowledge, the start of of an I2C transaction, but all that seems fine. It's just that, again, coming out of reset, I find certain lines, data or clock, are both pulled low for no obvious reason, and they just stay low. And the only difference between connecting and I don't have the problem when I connect the B&O to my Arduino Mega. Same setup. I have the B&O and the OLED, same OLED, connected on the same I2C bus to, in this case, the Mega. And in that case, everything works fine. I have not seen that issue. I mean, the main difference is everything's at 5 volts, right? I'm giving the B&O 5 volts into its, 5-volt input and so on. And, the moment I connect things to my SDM, well, everything's 3.3 volts. So that's kind of one difference. I don't know if the B&O 85 just, doesn't operate reliably when I feed it directly with 3.3 volts, compared to when it's fed with 5 volts. I mean, it's just one theory. But again, it's one of those things I just end up spending, unfortunately, a bit of time just trying to get that resolved, because I really would like that to work and understand why it's not working, so I can, do more things with that. Yes, do I have the Adafruit or SparkFun? Now it's the Adafruit B&O 08X module, which has the 8. The X is the 5 here. It's the 85. And yeah, I've been having good success with it. Just going directly to my Mega, but not so much success going to the STM32.
Is it behaving the same when it's by itself, or have you tried other devices than the OLED?
I think I'll have to collect more data points there. I did disconnect the OLED. Same issue, basically. I don't get, I can't quantify the difference. I don't get 100% success rate, and I really shouldn't be any issues, right? I mean, and I have never seen any issues with the Mega. So the short answer is, doesn't seem to be an improvement when I disconnect the OLED and leave the B&O just by itself. Because sometimes I don't even find it. Just coming out of reset, it'll a lot of times it'll complain right away about some I2C timeout and not even finding the device on the bus. So I mean, either I'm doing something wrong here that's not entirely obvious to me. Again, it's not even moving my B&O board around. I'm just connecting my I2C bus wires, from one board to the other. So whatever I have connected in terms of inputs and reset, and whatever I leave dangling, floating, it's the same between the two setups, and everything is supposed to have pull-ups and whatnot on the B&O. I think it's only the reset line that you're supposed to tie to, to VCC if you're not using that input. And so I do the same things, as far as I can tell, when I use the Mega and when I use the STM32, but I don't get the same results. So again, one difference is 5 volts versus 3.3. Other difference is a different micro, obviously. I'm actually running the same. I'm not running the exact same code, but that's, I'm using the exact same SparkFun library. So I'm using the SparkFun library to talk to the Adafruit board. So yeah, it's again, I suspected initially something funky about the I2C implementation on the STM, but I don't think that's the problem. It's clearly the B&O, for whatever reason, pulling and holding its lines low. And, once that's the case, I can't even talk to the OLED, right? So when I get into this funky state, I can't talk to the OLED either. The whole I2C bus is dead at that point. It stays dead.
You're supposed to have pull-ups on the clock and data lines somewhere.
Yeah.
Have that, or?
I mean, right now, this very moment, I don't, and I think there are some pull-ups enabled internally somewhere. I'm not 100% sure. That said, I did try with explicit pull-ups added from my end. That didn't seem to help, but I'll probably try that again just to make sure I didn't make a mistake there. I know what you're saying, but I thought, there's some weak pull-ups at least enabled inside the micro.
The STM.
Yeah, I could be wrong on that.
Yeah.
And therefore I really should explicitly add pull-ups. Again, when I And I did that, or I think I did that. I mean, I can't really make much of a mistake there. I just didn't really see an obvious improvement.
Yeah.
Okay, so Adafruit shows a 10K pull-up. Yeah, so that's what I thought. I mean, I thought I read something about pull-ups being there, and so, yeah.
Okay.
Is there an Adafruit library instead of the SparkFun one?
There is. It was a little more convoluted, and I couldn't figure out how to convert everything back to the angles I wanted. So I just found it harder to use the Adafruit library. And I've been using that SparkFun library ever since I got that device, and I haven't had an issue in using that library on the Mega. Now again, when things initialize correctly, then they work. Oh, that said, I mean, I have in that pattern I don't get today, but a couple of days ago, the pattern I got was even stranger in the sense that things would come out of reset properly. I would start getting data and would, printfs, the data. And then after maybe a second, and sometimes after 5 seconds, boom, it would flatline. And so I don't know what's that about. I don't get that particular behavior and symptom today. I don't know why. Again, I've certainly mucked around with things a little bit. So but that was sort of what I got initially. It was working for a little bit and then stopped. And now it's sort of okay. If I succeed coming out of reset, well, then it's pretty solid for, I haven't run it for an hour, but at least it doesn't stop, quickly like it used to. But more often than not, it just doesn't even come out of reset properly.
Huh.
So yeah,
Chris,
so like I said, I only today, managed to get my hands back on my logic analyzer. So I the last couple of days when I spent time on this, I couldn't really observe what was going on the bus, and so now, with that on hand, maybe I can spot something, but all I can see so far is, well, somebody's pulling the bus low, and there isn't really anything going on in terms of, there's no noise on the bus from what I can tell, or some other garbage going on. It's either valid transactions are happening and everything looks dandy. I can be using the Pulse View software there from SIGROG, right? It'll happily decode I2C, and it shows me who it's talking to, whether it's the OLED or the B&O, and everything looks good. When it looks good, when it comes out of reset properly, it seems to be doing fine. But when it doesn't, then it's just stuck.
Chris, do
Yes.
you have pull-ups on the reset line itself?
So I had the reset line of the B&O tied to VCC initially. Now I'm explicitly controlling that reset, which does seem to help. Right? In other words, I either do a power cycle or I reset the STM32, and one of the first things the STM does, it's pulling that B&O reset line low for 50 milliseconds and then releasing it. And again, I don't have it quantified, I don't have it measured, so, but my gut feeling is it's increasing the success rate of the startup sequence succeeding.
And then another thing that might be different, the STM has pull-ups and pull-downs, and you can also drive the output as a push-pull, or you can drive it single-ended. And I just wonder, those are all slightly different, open collector or whatever. I wonder if there's some there.
Open drain.
Yeah, I'd have to drill in what the code, the way I was programming this. I wasn't using the STM32 Cube IDE for this. I was using Platform IO and the Arduino framework, and so it's doing what it's doing right behind the scenes, kind of a bit of a black box. I tell it which pins I'm using for I2C, and I know enough what's going on inside the black box. I know it knows which pins are valid I2C pins. So I kind of hope that Arduino core is initializing those pins correctly, you know, for the right output mode. But you're right, that could be a problem.
Of what might be other differences between it and the Arduino.
Yeah, but then again, when it works, including clock stretching, right, where the B&O again is clearly able to successfully hold the clock line low, you know, in 800 microseconds later, or usually it's more like 400, you know, releases the clock line and everything continues. And so that has me thinking that things are fine in the pull-up department.
I guess it does. The B&O does have a UART interface. I wonder if all your problems would go away if you tried that. It might eliminate something going on.
That
maybe a pain in the butt to do.
That's true. It also has a SPI interface. Yeah, I thought about trying that as well. You're right. The UART interface, I think, is only intended for use with one particular operating mode, the robot vacuum cleaner mode. I'm not sure if that's identical to the game rotation vectors that I'm using, or if it's a little different, or if less data fusion is taking place. I'm not sure, but it does have SPI, and the SPI mode is supported out of the library. You just have to kind of, you know, set things up.
Yep.
So I could try that, but it's just, yeah, I mean, it's just that, okay, if I'd like to understand what's going on, because I want to use the STM32, right, as a I/O hub or I/O coprocessor. Yeah. It's got a couple I2C ports, which is one of the reasons I'm fiddling with that, right? And so if I don't understand why it's not working, then I don't have much faith that I can do other things with it.
Yeah, that's true.
So.
Doug, when you used that device, did you use the I2C or did you use the UART interface? Doug, are you there?
Doug's on mute.
We can't tell because you just have a picture. I think he's gone to the.
No,
he's putting things in chat. I mean, I can tell you that I'm using IMU. I'm using the BNO 55 via I2C on Omega, and I haven't had any of these issues. But it's the only thing on the I2C bus, and it's Omega. And I think I'm using the Adafruit part on the Adafruit library. So,
okay.
I'm not.
Yeah, so I, you know, on the Mega with another device on the bus, I'm still good.
Yeah. Do you see any like invalid logic levels at any point? I mean, you know, sometimes, you know, data analyzers may not show that, but
you're right. You're totally right. There could be, again, one of the differences is on the Mega, everything's 5 volts. I'm feeding 5 volts into the B&O and so on, right?
Yeah.
On Chris, on your OLED, on your STM32, are you feeding at 3.3?
When I'm connecting to the STM, everything is getting 3.3. I'm not, you know, I'm just double checking here. I'm not looking at the 5 volt output. I'm often powering it from USB, the STM. So I technically have 5 volts available, but I'm not tapping into that at all.
Yeah.
Everything is getting.
What's getting fed into the VN pin on the BNO? 3.3 or 5?
So VIN, so when I'm on the STM, I leave the VIN open and I connect 3.3 to the 3.3 volt pin.
I'd have to look at the circuit for that one. But one of the things that I do know that can get you in trouble sometimes, you got to remember that if you have 5 volts and 3.3 volt.
Well, I'm not mixing, keep in mind, I'm not mixing anything here. When I'm on the STM, everything is operating on 3.3 volts. But you're right, I know there's a VIN input pin and then there's a 3.3 volt pin. And honestly, I didn't read the manual. So shame on me, because I don't know if I'm supposed to feed 3.3 into the VN pin.
Or it's supposed to be an output, but I don't know if that means, I don't know if you put nothing on the 5 volt pin. I don't know if 3.3 fed into the 3.3 pin would be power the bus, but it must because you're working. Now the question.
Yeah, I just fed 3.3 into the V in pin, hit
Mhm.
reset, and then I'm able to talk to my OLED, but then it gets stuck. So
but if you have multiple pull-ups, that's bad. And if the pull-ups, even worse is if you have the pull-ups at different voltages. Okay, because
they would all be the same voltages. Again, they would all be the same voltages. I got no 5 volts anywhere in my circuit here when I'm on the STM.
There's a possibility that 3.3 volt isn't getting high enough to register a 1 or whatever is going on to trick the logic, depending on the speed you're running. I've seen that sort of happen, or I've heard about that happening. I don't have an O-scope right now, but
but that would only be an issue if you are feeding 3.3 into a circuit that's kind of expecting 5, right? But in my case, everything should be expecting 3.3 because I'm feeding, everything is getting VCC equals 3.3.
Yeah, I got it. Sorry.
The other.
Still, it does seem significant that that's really a major difference between the two setups.
Yeah, I mean, yes, that's. I guess you know. I mean, I may have tried that, but I need to make sure I double check. I guess I could feed. Right. I mean, the STM is 5 volt tolerant, right? So I could feed 5 volts into the B&O, and yeah, I could feed 5 volts into the OLED as well.
First thing I'd try, Chris, is simply moving your 3.3, the pin you got to 3.3 volts, you know, what the power in that you're using on 3.3, just move it over to the 5 volt pin.
I just did that, hit reset, and it got stuck.
It got stuck, so that's not help fixing the problem. Okay. Then I'd say, what happens if you put 5 volts on that pin?
Yeah.
You have 5 volts available somewhere, don't you?
Yeah, I have it available. So I think I'll try that, you know, while we're talking, and maybe I'll report out later. But I'll try that. I thought I did already, but I'm not sure I was paying attention. So I gotta try it again, and make sure I'm doing it right. But you're right. I gotta give that a solid try. Everything on 5. Well, I mean, okay. So in that case, the STM will output a 3.3 volt, you know, clock and data signals, and then the slaves will come back with 5 volts, right? I mean, so what should the pull-ups then go to? That's the question, right? Should the pull-up go to 5?
Pull-ups should go to 3, I believe.
Yeah.
All right, you should, and that's another potential error. Like I say, if you have multiple devices, you know, and some of the pull-ups are going to 5 volts and some of the pull-ups are going to 3, weird things can happen. All right, but you want to, you know, if you got a 3.3 device on your system, you probably want to pull it.
Yeah.
If you had level, you know, what do they call them? Voltage level shifters.
Yeah, I know what you mean. Those level shift, level shifters. I have some of those.
If you had those, you know, you'd want the 3.3 on the B&O side. And if you were using the 5 volt bus outside of that, you'd want the 5 volt bus on that.
Yeah.
But if you're not doing that, just put a 3.3. But what Harold said about occasionally you get a device that doesn't quite make to TTL spec, and then that'll screw you up. I've had, I guess you call them marginal chips, where they just can't make the 2.2 volt TTL level for 1. And you know, they get up to like 2.9 or something like that, and they just don't quite do the job.
Yeah. The other thing, just the other thing I've observed, and again, I haven't collected 100 samples and calculated the stats on it, but it felt like doing a power cycle delivered a higher success rate compared to just hitting reset on the STM32.
Mm-hmm.
Again, I don't have it quantified, but it sure feels a lot like power cycling the whole thing is more likely to succeed on startup than just hitting the reset button on the STM.
Yeah. Yeah, because I don't think I ever used the reset. You know, I put it to whatever value they said. Actually, I don't even think I've got. No, I don't even have a wire to the reset pin. I don't believe.
Yeah, I found it felt, even when I used that B&O with the Mega, it felt like, okay, I gotta explicitly tie the reset input to VCC. Otherwise, it didn't seem rock solid in operation.
Mm-hmm.
And that's what I believe I've read that in the documentation.
Yeah, that's probably true. It's probably true if they got it in the documentation.
Looking at the schematic of the B&O's 085, it looks like the 3.3 volts is the output of looks like a linear regulator, the AP2112. So you probably, well, it's difficult. I'd have to look up the specs of that chip as to whether that could tolerate, driving its output with 3.3. It may not like that. But it does get, its supply from the 5 volts from the VCC. There are 10K pull-ups on the I2C lines.
That's a good idea.
On the part, on the B&O 085 in the schematic. So.
Hey, Ray, Chris, what if you put the 3.3 volts on both pins? Because if you're saying Ray's saying the regulator is actually getting its power from the 5 volt, the VN pin, I think they call it.
Yeah.
Okay.
See if that does anything.
Yeah, on all the Megas, you actually, like when you don't have a power supply hooked up and you have USB hooked up, you're actually connecting 5 volts to the output through a diode to a similar regulator. It's just another, I think it's the 1117, another linear regulator, and you can do that. It's not supposed to hurt it at all. I mean, that's how the boards, pretty much all those boards are set up. It actually gets driven through like a Schottky diode, so there's not much drop.
Yeah, and I actually, one of the things I've often, on a 11117, I think the dropout voltage is about a half to 1 to a half of a volt. I can't remember exactly. So feeding 3.3 into the input might not be enough to actually get the regulator to regulate.
So I've connected now both inputs like was suggested, and same result, and I just captured the trace here. And so again, what I see in my trace is the SDA line is just being pulled low and
Okay. Yeah, I
guess the water.
You haven't tried putting 5 volts on the V?
No, I'll try that a little bit later and
with
some wires here.
May solve some
Chris, for what it's worth, I've run the STM32. The boards that I have, those Nucleo boards, run off 5 volts, and they have a 3 volt supply on them. But whenever I've needed to talk to a 3.3 volt peripheral, I've always used those little level shifters. That's kind of a pain in the ass because, basically you're putting yet another little tiny card in between them.
Yeah.
But I've always...
I'm confused about what you're saying, right? Because the STM parts, they're all natively 3.3 volts that tolerate 5 volt inputs, but they will put out 3.3. Is that not correct?
STM parts, yeah.
The TTL, CMOS or however it's done, signals you're saying you believe are 3.3 volt signals?
Yeah. I mean, the boards that you're using, I mean, they obviously, they have some power conditioning on the inputs, some linear regulator, I'm sure. But I'm 99.9% sure the STM part is natively a 3.3 volt part, 3.3 volt logic, and that's at least the good part about it, it'll tolerate happily 5 volts on most of its inputs. But when it puts out a signal, that'll be a 3.3 volt high. A logic 1 will be 3.3 volts coming out of it. Pretty sure.
Okay. I got my scope right here. I'll look.
Here's a question for you, a little bit different. What about reset timing? Because you got 2 different microprocessors. Could it be that like one's coming out of reset before the other, and you need to hold the B&O and reset longer before you let it wake up, something like that?
Yeah, actually, you know what? You could be onto something, right? Because on the Mega, you know, just the way this whole that thing is resetting, and the bootloader comes up and it tries to figure out, should I be doing something, right? I haven't measured it, but there is some time involved there in the Mega starting up. So you're totally right. I mean, maybe I need to,
Like
you know, I'm already explicitly resetting the B&O device just to have control over that. So what you're then saying, basically, maybe I should just wait a little while longer before I start talking to it.
Yeah, or give it some delay. Like I know when I set up this 5-port between the Raspberry Pi and the Mega, I have one of those level shifters to go between them. And as I think back to it, there's like an output enabler, there's a reset or something. And I remember I had to do something specifically to wait before I enabled the level shifter, or else it wouldn't wake up properly. And the interface was screwed up. I forget the details on it, but
There's also an issue of when the power comes up versus when you do the reset.
right. Yeah, I mean, it's just going way back to the 80s when I was doing my first laser rangefinder with TTL 7400 series stuff. And you had to make sure that you made sure all the chips were, because the chips would reset at different thresholds as the power came up. So some would come out before others, and you had to make sure that to get a clean reset, everything was powered up before you released the reset. So I had a separate chip to do that in the 80s in the discrete world, but
Yeah, so you know that's a good idea. I mean, and I just did that literally. I added a 2-second delay after resetting the B&O, which I do explicitly now in software, right, through GPIO. I'm gonna, you know, hold it in reset.
I mean, it's a peripheral, right? So wait till your main micro gets up to speed and is happy, and then let the peripheral come out of reset.
Yeah, I mean, my main micro comes out pretty fast, right? The STM32 is going to be quick. I'm more wondering if the B&O needs more time.
Yeah, sure. Yeah, before you try talking to it. Yeah.
Yeah. So yeah, I'll try that. Good idea. So that and the 5 volts. I need to try that.
And the other thing, Chris, and this goes back to why I don't like I2C, is did you by any chance wiggle the wires? If you wiggled the wires and it got better, maybe not perfect, but got better.
Yeah, I know what you're saying. Yeah,
it's just, you know, it wasn't made to do what we're doing with it.
Well, it's all short distance stuff, right? I mean, I don't even have any motors running. I got no noise going on here, nothing. It's just, this should really work. This should really work.
But like I say, if you wiggle the wires and it gets better, you wiggle the wires and it gets worse. It's sort of thing to think about.
I mean, I also tried bringing the I2C clock way down. You know, that didn't really seem to help. So
yeah, looking at the schematic of that part, the SDA MISO TX and then both clocks in the RX, the pull-ups on that side go to VCC, which would be your 5 volts. On the other side, it's actually labeled SDA _ 3 volts and S clock _ 3 volts. So not, long story short, I think if you hooked up the 5 volts to the B&O and, you know, let its linear regulator generate the 3.3 volts, it may actually solve something.
Yeah,
okay.
I do think the delay and the reset probably is a really good idea.
Yep.
So I think you got some good ideas.
Got some ideas here. Yes.
Yeah. Pull it low, wait 1 second, delay, and then
Then add a couple more Band-Aids and it should work.
yeah. Hold your mouth just right.
Get some duct tape and a bigger hammer.
If you're going to put 5 volts on the BNO, make sure that your pins on your STM32 are 5 volt tolerant for your I2C.
Yeah, but didn't Doug just, or Ray, was it? Did you just said ultimately what comes out of the BNO is going to be 3.3 volts anyway, right?
It's going to be level driven to your VIN.
Oh yeah.
Well, the pull-ups on the input side are tied to VCC.
Yeah.
And then there's, the level translators, and the signals on the other side are SDA_3V, 3 volts, and S clock, _3V. So
when I was looking at it, that looked to be like the BNO side, the 3.3 volts. And the VCC side looked to be your pinout.
Yes. Yeah.
So that's why I'm saying if you're feeding it with 5 volts, you could probably expect, because of the pull-ups, 5 volts coming back.
All right, so I'm just
values. It's like 10K each on each line. So.
All right, so far I got a success rate of 5 out of 5, and that's a combination of, oh, nope, number 6 failed. So I'm feeding 5 volts into the VN. I added the delay on startup,
and still,
again,
50%.
success rate is not 100%, which it really should be. There's absolutely no reason why anything should go wrong here.
And the third thing is you listen to us, so.
Chris, I just checked. You are correct. The output is 3.3. My level shifter is to drive TTL signals. I'm sorry, RS-232 signals.
Okay.
So that's unrelated.
So yeah, I don't know. I got 5 volts going on here now. Maybe I need to feed 5 volts into the OLED also. That would be good. Now I have 2 different. No, but I'll fiddle with it some more. But at some
you need
point,
some of that blue smoke, not the black. You need the blue smoke, not the black smoke.
Yeah. It really shouldn't be that hard, but unfortunately it is.
Isn't that true of all of robotics?
It's those things that get you stuck for a week. You're just trying to read a damn sensor value, right? And it just sometimes that's where the holdup is.
That's our motto.
It's okay. When I was working at DSC Communications Corporation, we were developing, some T3 interfaces. It's like 44 megahertz or so, 45 megahertz. And you would put in use a pseudo random pattern generator to test your circuit, and it would run all night. And I'd come back in the morning and I'd have one error out of, bit rates of 44 plus megahertz, so there's a needle in a haystack for you.
All right, thanks guys. I'll try a few more things and we'll see if I can figure it out. Yeah, I'll probably have to switch to SPI, but again, yeah. Who's to say that?
The most confusing is that it seems to work in the one environment and not in the other. And it's R²C in both of them. The hardware is the same. It's coming at a reset the same. It seems like the clue must lay there somewhere.
Yeah, but it's definitely not software, right? Because I can see the line being low right out of reset, right? Before any software even runs, at least on the STM, that line is low. Now, unless the STM itself is not doing the same thing every time coming out of reset, right? Again, I'm kind of assuming that is this Arduino framework that the platform IO framework is pulling in all the big black box there behind the scenes. I kind of have to rely on it doing things correctly. But like I said, and maybe I got to pull the BNO off and take maybe a couple samples. I want to make sure at least 20 out of 20 times I can talk to my OLED correctly, right? Just to make sure I'm not, I have my numbers here correct, because that would suggest there's really nothing wrong on the STM side, right? If I can prove that the STM can come out of reset correctly every single time and talk to the OLED every single time, but that the B&O is pulling one of the data lines low, well, then it's got to be with the B&O. And it's got to be related to this whole voltage business, right? Even though I thought I eliminated that variable, maybe I didn't. I need to look at that more closely, right? But things are pointing in that direction right now. That's the main difference. The difference in voltages. That's on top of my list.
I guess the other thing I'm assuming you've probably already looked somewhat. There's forums, that you can look at to see if somebody else is suffering a similar plight. Is there a known problem with the B&O 085 or something on I2C or coming out of reset or something?
Yeah, I should Google. I did do some Googling. I didn't see anything obvious, but
yeah.
I didn't try too hard to find stuff. So.
And you have your logic analyzer, and you've hung probes on every line and watched them go up and down, and they're all doing what they ought to do.
Yep.
That's when you say it's time to take up knitting.
Yeah.
Yeah, this makes my head hurt. So
Or time to take a vacation to the mountains or the beach.
Okay, that's
time to go finish that basement. It's more hammer and nails.
Keep buying that lumber. You're doing us a favor.
Yeah, why is it so highly priced now? What's going on with that?
I was just looking today. Random length, I think, is above $1,200 a 1,000 board feet. Keep
Jeez.
going. It's never been that high.
I know.
It's half that price is normally the high.
Wow.
Yeah.
So needless to say, I got a good bonus coming.
There you go.
Is that why I'm paying $6 for a 2x4 these days?
What's that?
Is that why I'm paying $6 for a 2x4 these days?
It's $8-9 in Canada.
Oh man. Okay.
Now, if only that was crypto lumber, then it'd be really hot.
Yeah.
Oh yeah.
Maybe it's the pine bark beetle. I don't know. Do you think it's affecting the forest that much, or?
Well, the Asian pine beetle in Western Canada, probably the States as well, has shut down a lot of the sawmills out there because of all the dead wood that's out there.
Yeah.
So now it makes it dangerous to go harvest wood because you got all these trees ready to fall on you.
Mm.
So, add to that all of this dust from the dry trees, burnt down a couple sawmills. So Western Canada lost about maybe 8 or 10 sawmills.
Wow.
And there isn't enough in Eastern Canada to make up for the slack. Add to that a couple natural disasters in the US, COVID, where everybody decides it's a good time to work on their basement. It's the perfect storm. So when you make your living in the lumber industry, it's a good time.
Nice.
Yeah, I couldn't believe that when we went out there. It's like, especially around Banff.
Yeah.
50% of the trees were, brown and dead apparently. So.
Yeah, there is. So when you look out there, everywhere you look is a sea of orange on the pine trees or the spruce trees.
Yeah.
And I've got kids that live just around the foothills coming into Alberta. My 2 boys, and they're in the area where it got cold enough that it's killing off the beetle.
Oh, okay.
But in the mountains, it's funny how it goes. Unless you're in the top of the mountains, the tops are still green if there's any trees because they're high up. But halfway up the mountain, everything is orange.
Yeah. Yeah. So are they able to harvest that wood and use it for distressed flooring or something, or?
Well, they did for the first few years. They were harvesting the dead trees because there was still enough moisture in the dead tree to cut it and mill it and do whatever. But after 4 or 5 years, they become too dry, too brittle. It's too hard to work it. So on top of that, to sell it in industry, it has to be heat treated. So you got to bring the internal temperature, I think, to 185 C to kill off any bugs that are in there.
Yeah.
And by the time it comes out from just heat treat, it just explodes in the planers.
Wow. It's just too much stress or tension in the wood. Huh?
Yeah, it's too dry.
Wow.
Okay.
Now you know everything I know about sawmills.
There you go. All right, let me make sure. Am I presenting the right screen? Let's see. Nope, I'm not presenting the right screen. Are you seeing
I see
photos
every.
of yourself or my Word document?
No, I see
Okay.
your screen of all of us.
Ah, just a second. You'd think
I
knew
like
how to
the
correct-
so that's fun.
Okay, this should be better then, yeah?
Yes.
Right,
Word
we have the
document.
monitor. Okay. All right, so I'm going to give them an update on the telepresence robot stuff. And so, you know, there's a handful of us that have, in theory, we have a target to get through that AWS example that Donna found, which is a two-part example. And Chris did awesome out of the gate. He blew away part one in like a week's time. I don't even think he slept or anything, but so then the challenge was on part two, and for the rest of us to catch up with Chris. So I have since then, I've done part one and almost all of part two. And I also did a part of this. I did all of this one, which is pretty good actually this is an Amazon Web Service. But I have a demo part of this in a minute, but I thought I'd give a summary first. And the basic summary is that the part one, I think, is pretty easy, relatively easy for the novice. If you haven't done this kind of cloud platform serverless kind of thing before. Part two has a lot of valuable lessons, but boy, is it loaded down with a whole bunch of mumbo jumbo that you got to work through. And it's, you can do it as a novice. It's worth trying, but it's don't expect to get through it without a little bit of head scratching. And then Amazon Web Services, they have a whole ton of different modules and services. And I find that, these two are going to be pretty useful or could be, but at least as benchmarks, they will be. So Kinesis is the one that serves video. Chris had already mentioned that one. But this Cognito is their one that handles identification so that people can log in to your robot, or the robot can log in, or you can log into the server. And then on Kinesis, I'll show you some of this stuff in a minute, but I found that the SDK that you have to compile on the Pi to serve video, well, somehow it introduces this 2-second lag, which, okay, at least if it's fixed, that you can deal with that. But the worst part is that it seems unstable. So it doesn't hold a connection very long, and sometimes it doesn't want to start up. And then I've noticed that on a Pi 3 or 3 Plus, I'm not sure, but it chews up 80% of the CPU just to stream the video. And wow, I don't like that. And then also, like, there's a couple different modes to run this service. One is like video streaming mode. That's where you start to incur costs, apparently. The other is signal channel mode, which I think is peer-to-peer WebRTC. And you can do this in the free level. So I think it has to do with this peer-to-peer signaling channel. I think that's what's driving a lot of this 2-second lag and some of these other issues. But as a benchmark, I found it pretty interesting, pretty useful. And the reason I didn't finish part two was that I was having some strange issues. Well, for one, there's these instructions, and I don't know if it's the instructions or my attempt to follow the instructions, but between that and the source code, there's definitely some issues in the source code, and I just couldn't. The first time or two I went through it, it was screwing up. So I tried it again this morning, clean. Same thing I did last night, and this time it works, parts of it. So anyhow, that's at the top level where I am. And now what we'll do is we'll switch to a demo. And so what I'm going to show you is basically at the highest level, it's like this. There's a web page that you run in a browser. There's the robot, which has a little piece of software running on it. And in the middle is Amazon Web Services, a couple of different versions of them, right? So they talk to each other through the Amazon Web Service. So I have what I'll call the robot client is running on my Club Car Donkey bot. So that's, if you remember, it's this robot here. Oh, now I've done it. Good move, Carl. Which one? Not that one. This one. Nope, just a second. It's this one. Okay. So that's, so the robot client, oh, sorry, I've got one more window, just a moment. The robot client, so on the Pi, it's registered with Amazon Web. I think it's IoT Core using a protocol called MQTT. So it's not HTTP or SIP, it's MQTT. And then the web page, what I'm going to show you, is running in local debug mode on my laptop. So I have a small web server on my laptop, and that's feeding the browser. That's the part I ran out of time. So I think I should be able to get it to serve that web page in the cloud. But and then there's all kinds of Amazon Web Services stuff that connect those together. I still don't have all the interactions together figured out, but we can pull up the tutorial diagrams if you want to see. But basically, so I have a camcorder here. The reason you can't see my face is that I have an external webcam pointing at the robot. And then this is a VNC now. So I shelled into the Pi's on top level of this robot. So this is, in this window is the kind of robot client that's talking to Amazon Web Services. And then this is a web page that's getting this web page from, it's a single page web app, I guess, but it's pulling it from the server running on my laptop. So before I start clicking buttons, any first questions out of the chute? Okay. So the good news is that now, and you can see I have the robot picked up off of the stand, so it's on a tabletop. So if I turn the robot to the right, it turns to the right, it's right. And if I turn to the left, it turns to its left. And if I move it forward, it tries to move off the table. So basically, that's encouraging.
What's the delay on the commands that you're issuing approximately?
You know, I haven't tried to measure it, but let's just see. Let's say that I hit this button, so I'll go click. It's not too bad, I think. Go click the other way, click. I think it's actually quite reasonable compared to the video. It's quite reasonable.
About a second, maybe?
Say what?
It looks like about a second or so.
It's under, I'm sure it's under a second. But basically, you know, what's happening is that I click this button and it's sending this web page. I don't know if it's using the server or not, if the web page talks directly, but it's sending a command up to Amazon Web Services, and that's turning into an MQTT message that shows up on the client down here. So if I hit the forward button, you see it show up as a forward back here, backward. So, so it's all working through the cloud. The only thing is that this is served locally, not in the cloud. So that's the good news. And it turns out that at least that part of it, the client on here, and even my spy since like 8 in the morning has only registered 8 transfer failures out of 20 hertz since like 8 in the morning. It's only had 8 transfers that had an issue. So the spy port that I made is pretty robust. And yeah, that's since about 9 this morning.
Excuse me. You believe that the latency that you're getting is kind of best case here because you're really not going across the internet and coming back from the cloud? Is that what you're saying?
No, contraire. I'm saying it is real world because it's going from my browser up to the cloud and back down to the robot. So the only difference is that this web page loads from localhost instead of Amazon in the cloud. That's the only difference. at least for this part. Now the video is another matter entirely, because I haven't figured out its routing yet, but for sure this goes up to the cloud, and so I have a window over here. I can make the same thing happen. Like I have another shell window on the Pi, and if I run this curl command, it'll send a forward from the Pi up to Amazon Web, and then Amazon Web will come back down to the Pi. So if I hit enter, so I'll hit enter, and that's routing through the cloud for sure. So so that's the good news. Then and it's going to run off the. So now this is the troublesome part, because when it gets to this video, and right now you'll see like watch my meter, CPU meter says 86%, right? It's just sitting there, it's been there all day long. And if I try and open the video window, and I'm going to open the debugger, the Chrome debugger. So if I try and open the video, you can see that it sends all the right traffic back and forth. It's got some kind of stuff going back and forth there. It's got whatever this communication means. It's trying to do something, but it never loads. So now comes another bit of fun. So I'll stop it here. Oh, and there's something else to show you too. Here, that's cool. Don't let me forget that.
Did the video work for you after you finished just part 1 of this tutorial?
Oh, okay, yeah. So I can.
So in AWS, yeah, right. The video in
so
part 1.
If we go to the Amazon, this is the basically control console for the Amazon Web Services Kinesis service. And if we open their little test thing, the media playback viewer, and I click this, yeah, it never. Right now, it's not going to go anywhere. And why? I'll show you why in a moment. It's because the client over here on the robot has crashed, or the video Kinesis SDK part of it has crashed. So to show that, what we'll do is we'll leave this web page up and running, right? And I'm going to show a couple things at once. So first, look at I have a mirror here, because on the back side of the robot, right about here, I have these little lights that show status, and this one right here is a yellow one. So watch what happens when I halt the client on the Pi. See how that yellow light went out? Oh, and now it actually said segmentation fault. So I think that's the Kinesis thing that has the segmentation fault. So we'll clear that. But you see how now now watch what I'll do is I'll start up the client here on the Pi. So this is running on again, this is a VNC window to this Raspberry Pi. And once it runs, then you'll see this little yellow light come on here that indicates that my SPI bus is running. So when the yellow light comes on, that's when you know that the Pi is talking successfully to the Mega. It's the Mega that drives the wheels, okay? So I'll launch the client. It goes through some mumbo jumbo, and now it's connecting to Amazon, and then you see the yellow light come on. Okay, so now the SPI port is up and running. And now all I've done is I've left the web page up and running. I've just restarted the client on the Pi. So now what happens when I click open video, 2 seconds later, prove me wrong. Nope, 2 seconds later, there we are. Woohoo. So.
Yeah, so now if you close this video and then try to open it again, then it fails?
Yes.
I think that's what I've seen also with just part 1 of the tutorial. At least more often than not, that's what I've seen inside the AWS console. First time pulling up the video always succeeds, and then subsequent times, yeah, it's like hit and miss. And I found that I had to restart the piece on the Pi. So I think similar observations here on my end with part 1.
You're finding the same things I did. Yep. So
Okay, but so the the 2 seconds, I think that is along the same lines that I saw inside the AWS console, and you're saying you're getting the same 2 seconds in the web page.
Yeah, in fact, you can I'll show you here. It's kind of cool. So what I'll do is I'll wave my hand in front, right? So here I'll start off here. Now I'll raise my hand as you go 1001, 1002.
Yeah.
Right. Start up here, 1001, 1002. So it's a 2 second lag. Doesn't get any better than that, does it? Unless you're on Mars or something.
From our end, it looks like it's 2 seconds ahead of time, like you're
Really?
2 seconds in the future.
Well, wait a minute. So
No,
this one,
you have to look at the bottom left corner, Dave, is the
real time.
Is
Or
the real
reference
time.
Reference time, we'll call it. That's my webcam, right? I can come in here and smile hello. So basically,
That's what I'm saying. The bottom left corner is ahead in time.
it's supposed to be.
Right. Oh, okay.
Right, because that's so basically this camera right here that I'm covering up right now, that camera's fed into my laptop, and that's what's driving this screen on this right here. So if that's the reference time, right? So the photons from my hand hit this camera at effectively the same time as it hits this camera, right? It's the same photons.
Yeah. So the delay is measured, from bottom left to top right. Top right is the slow one.
It's behind. And why it's behind? So this we got to figure out, Chris. Is it getting routed from because it's got this crazy peer-to-peer WebRTC? It's not incurring Amazon web prices. Kinesis calls it their signaling channel versus a video stream. So I have this kind of theory that says what this client that you compile on the Pi actually does is it uses it uses this signaling channel service in Amazon Web to broker a peer-to-peer connection straight from whatever path it can find from this device over to this browser. So I wonder if even this video it may or may not even be crossing the internet.
Oh no, it is. There's nothing going to be on your local network other than what's going to your gateway. I can assure you, it is going out to Amazon and then coming back in. Otherwise, it's just that they're just getting anything else to work. There's just too many firewalls in place on local computers and whatnot, right? You just can't. You can't make this kind of peer-to-peer communication work in all environments. But the only thing you can guarantee is that the Pi can get to the cloud, your web browser can get to the Amazon cloud. That's you can always guarantee that, and so it's always going out and coming back and going kind of the long way.
The only
the thing is. Okay, even though it has to go out and come back, that doesn't, that adds, let's say, 100 milliseconds of latency. You can't get lower than that, or let's say 150, right? Everything else is going to be the result of packaging stuff and buffering it again elsewhere, right? That's what's the latency.
Yeah, I'm with you. Unless there's some jitter buffer. I mean, I just don't know enough about this WebRTC. Yeah, that it's going to be an interesting thing to figure out. But and then so before I forget, then there's so here if you keep an eye to so the CPU meter's at 86. Now watch what happens if I close this. If I stop that video. So now nothing's running. So just with real VNC and whatever other stuff it's doing, 4 or 5%, maybe 0%, 1%. Okay, now if we start the client by itself, and this was a hello print to console lesson for me too. Now with the client running, it's still only under 5%, right? And it's there's enough running there that it's clearly passing messages, because I can move the robot, right? I can crash it all day. So and you can send multiple commands. Actually, that'd be something to figure out. But these cables are just power, by the way. I don't have it on battery. But you can see that the CPU meter is staying down there pretty lightly loaded, even with the other communication going on. So it really is just, it's not until you open the video that it just slams it. And then the funny thing is that even after you stop the video, it doesn't release whatever is going on. It keeps it pegged. So
yeah, maybe that's why the second time it doesn't run properly. It didn't release
well, it's still
the resource.
now it's been opening and closing pretty consistently. So I don't know what's. It's just not robust. It's caught Chris's BNO problem. Oh, there it is. It's crashed again. So let me see. Did I show everything? I think I did show everything. So anyhow, oh, no, I didn't show everything. There's one more thing that's really useful to show, and that takes. Let's see, how do I show that? So two more things actually. So the first thing is, you'll notice that it has this sign out button that we haven't looked at all. Well, you can click that. Oh, and look at this. You can actually create an account, or you can sign in. So this is all with this came along for the ride with the part 2 tutorial. So I created a login that's bound to my email. So that's where that Amazon, I mentioned the AWS Cognito thing comes in, because that Cognito thing, what that does is it provides all that sign in and sign out and the login and the user registration stuff. So, you know, when we get to the point of the DPRG thing, if we do the way I'm thinking of, we'll allow anybody to join, and then we grant them rights to use this robot or that robot. So that kind of facility can make that kind of process easy, right? And you think that's cool, because that's great. That can lock down access to your service and the robots. Well, and that's where, let's be a little careful about that. So I was really curious about what was going on under the cover. So I looked at the Chrome debugger here, and let me get to the right view. Where's the right view? Okay, that was the right view. So let's say we publish a forward. Just move the robot forward, and this we'll look here at the details, and that sends something to this URL right here. And what it sends is actually, where did it go? It's right here. It sent this payload right there. So what I did is I copied that URL over to this tool called Postman, and in Postman, see, I took that same, I took the same thing right here. You see how this is the name of my robot instance on whatever. So I copied that down to here. And then for the body, I just took the action forward, and I put that down into here. And actually, I'm going to change that because I don't want it to run off the table. I'll change it to backwards. And would you get the hello to that? So I didn't need any authentication at all, right? So as nice as it is that they provided this cool little login stuff on the demo, they didn't bother to attach to require this login to actually issue these commands. So anybody now that has rights once can now reverse engineer our API and grab a control of the robot without wanting it. So that's the part of the demo that they failed on when they wrote it, that we would want to patch when we get to that point. But now for sure, that's what I've done this week, and I just wanted to share some progress. Almost on our target of the 25th. And have I put everyone to sleep by now?
I don't
No,
think
I
I
think
can make
that's
it to the
pretty cool.
25th.
So I don't claim to be an expert on the Amazon web stuff by any means, but to the extent that I can help, if you guys want to try it and you get stuck, let me know.
So an observation, we talked earlier about using Zoom or some pre-made client like that for the audio video, because I noticed in your demo, you still don't have any audio, just like Chris did. So you're eating up the CPU on the video, you got nothing left for the audio, and then you got syncing issues.
Yeah, and that was my point all along from the very start. Basically, that I mean, real-time streams are a real pain to get to work well. And I mean, this was a convenient thing to try because it came along
Right.
for the ride, and we can see these services that are out there. But I think for out of the chute, I think we want to focus on drive commands and cloud architecture and stuff. That would be my recommendation, to get that kind of stuff going before we worry about trying to have video streamed directly from an onboard camera and microphone.
Agreed.
So, yeah. And I got to tell you, because you know, that part that I was showing of the robot just driving it around, that part's rock solid, and that's the relatively easy part from the part 1 video. All we would want to do, I think, if we stayed with the Amazon approach, would be to figure out what kind of authentication we want to start to use and kind of like architect that in.
I'm sure that maybe that example didn't, just didn't do it right. I mean, there must have the capability that it's tied together in such a way that you can't issue those commands unless you have authenticated. It would make no sense if that wasn't possible.
No, Chris, I'll guarantee you it's possible. I think I even know what has to be done. So I think, so there's a part in the tutorial where they show you how to bind the rights, the login rights. You have to bind those login rights to the Kinesis video channel signaling stream. So I think all you have to do is take the same approach and bind that policy to the Lambda function that accepts the requests to move the robot. And I think it's basically you set up an authorizer and then you attach it to the right policy group, and then you attach that to the other things. So yeah, so that's an interesting thing to check out. That's in my plate to try, as well as publishing to the web. But
I mean, you said, okay, let's get all the command and control working first. But unless you have some video, even if it's laggy, right, you don't know what command to issue.
oh, and that's still where I keep coming back to the tripod with a camera and Zoom on Wi-Fi.
And
I was just playing around with this here, and you guys don't know when I'm doing this, but I do. And I would say the latency is on the order of a quarter of a second, so maybe 200 milliseconds, something like that. That's pretty damn good.
Yeah, but you are just seeing your own view in your own camera. I mean, that is
Good point. Good point. That's
because
good point.
my video myself, I mean, I think it's even less than 250 milliseconds. I mean, it updates instantaneously, right? So whatever the web browser is doing, my video is going straight into that top left corner, right?
That's a good point.
But I've done this before, and so all you got to do is get another computer or your phone, log it into the same Zoom session, and then do that trick, and then you can see how long, when you move it, does it show up on the other client, because it's going across the web.
But I think Chris's point is that what I'm looking at, my own picture, is not going across the web. It's going straight
no.
from my
Yeah,
camera.
not right now, but I'm saying if you had two computers there on your network, you could do that trick and measure it. Measure the delay.
Yeah, and it's on the order of a second, I think. Last time I checked, I had that going either on purpose or by accident. I don't remember, but it was quite interesting though, right? Because all the audio and video stays perfectly synchronized, but someone it arrives at one computer maybe sooner than the other computer for whatever reason, right? I don't know, but on a given individual computer, all the audio and video is fairly well synchronized, right? But there was noticeable lag in that. I don't know what you saw with Google Meet, Carl, but I think there's noticeable delay there too. We're just used to it, right? Even with the delays, and when I talk, and by the time it gets to all of you, I don't know, maybe it's a second, maybe it's less, but I think by now we're just so used to that that it's not an issue anymore.
Well, we all look like a Japanese movie. Your lips are pretty close to in sync with your.
Also, I think there's a question as to, if you're actually going to drive a robot with a video feedback link, what's the acceptable latency such that you don't run into the walls and stuff? This is kind of ancient stuff now, but back in the before time, I worked at electronic music lab at the University of North Texas, and we did a bunch of tests to see what latency musicians would put up with between the time they pushed a button and the time they heard the sound. And it, sitting there at a keyboard playing, it was on the order of 5 milliseconds. And they could tell if it got longer than that, they began to complain about it. And I would imagine the same would be true if you were, say, driving a race car. That if there was more than 5 milliseconds between your input and the response of the car. So, if we're moving around at fairly slow speeds and lots of time to make decisions, I'm just not sure what is the spec here? What's the requirement? Or is the spec just as good as we can make it?
Yeah, I think you bring up a valid question. I mean, with sort of some of the hacks that I've done previously, and I don't know if you were in some of those calls, Dave, but I get the sense if it's within 100, 150 milliseconds, you can drive a robot around at moderate speed, right? I mean, it's all a function of speed ultimately. The more the lag, the slower you gotta go, right?
So we're talking about update rate of on the order of 12 hertz?
Not update rate. We're talking more about the lag, right? There's two important delays in the picture here for teleoperation, right? There's the delay from when I have a remote control or a phone in my hand, I press the forward button. It's going to be delay. Robot starts moving. The video camera of the robot picks up that movement, comes back to my phone. Oh, I see the robot moving in the right direction, right? So there's like a double delay here, and command and control is usually faster than the video. And so, but altogether, right, that's the delay you're looking at from you pressing a button and seeing the effect of that. And when you do that, with some of this stuff we've been playing around with, you do it on your local Wi-Fi network, it's fairly instantaneous, depending on how you do it. And you can control it fairly well. Once you add 100 milliseconds or 200 milliseconds, you got to slow way down. You got to slow the robot way down. That's for sure.
That's why
it's not update rate, right? Because on the robot, it's still doing what it's doing. Running everything at the same update rate. It's you're the human in the loop. Your update rate, your brain can't operate faster than 5 hertz if there's a 200 millisecond delay, effectively.
That's why, that's the way I was using that term, that you push the button, you watch the reaction, and based on the reaction you see, you change the input, and that's not going to happen any more than 10 or 12 hertz.
Yeah, and I would, again, from what I've seen, 10 hertz is pretty good. You can live with 100 milliseconds, you could easily remote control something, but you can't achieve 100 millisecond over the internet. I mean, the best I've seen is 150, 170, 180.
Well, that's a good number to know. So you say, however it's done, if we can stay at 100 milliseconds, that's a reasonable, for a slow robot, that's a reasonable control rate.
Yeah, I mean, it's a subjective thing, right? I mean, it's kind of, I think you have to train yourself to deal with that delay, right? Because when I'm remote controlling my Romy here, and no video at all in the loop, just me pressing a button, looking at the Romy, right? There's practically no delay, instantaneous feedback. You know, you can zip it around pretty fast. You know, and so as you add delay, you just have to train, I think, your brain to deal with that. That's the bottom line. You got to slow it down, and you have to deal with that lag, just like some people can't deal with the lag on a long distance phone call, right? When I talk to my parents on voice over IP or whatever, right? Nowadays there's always a little bit of a delay. You don't get an analog connection anymore, you know, from here to Germany. They're still having difficulty with a 150 millisecond delay or whatever that is, right? They haven't gotten used to that. I think we are used to some of that, but you have to get used to that.
That you can train yourself. Referring back to those earlier experiments, the musicians, if you tested organists, especially pipe organ players, they're used to a lot of delay between the time they push their key down and the time the pipe sounds. But if you're talking to a percussionist, you know, he's the one that gets a excess of 5 milliseconds. He says, "This is wrong. I can't play like this." You know, it's meaningful to him. So there may be some way to train your own gray matter correlators here to adjust for that.
We can't hear you, Carl. You're on mute.
Carl, you have no audio.
Significant delay.
Now I have audio. Okay, right?
There we go.
Yeah. Okay. Oh, that's a drag. Okay. So yeah. So I would say that there's in reality, we're never going to get to 5 milliseconds, right? From Chris's experiments, we'll be lucky to get to 100, 150 milliseconds with our non-professional kind of hacky approaches, especially that, without knowing all the tricks of the trade till we figure them out. So it seems to me that the spec ought to be something like, you know, we do as good as we can without knocking ourselves out and trying to move mountains that won't move. But then we go a bit further and we think about the difference between driving, where you're a part of the poles and zeros, the control loop of real-time driving, and we step back and we say, yeah, but the other mode is to give it guidance. I want to go over there and let it figure it out and let it do it without crashing into anything. And I think, to me, that's where the interesting part of this game really ought to be, where a lot of our skills could come together from the kinds of robots we've done before. So I'm looking at my other monitor now and I go, let's see, if I go up, it's got to be a quarter of a second or a half second delay from here out to the internet and back to my other monitor. It's not that much.
So your analogy is that it's more like driving the Mars rover and less like driving a remotely piloted vehicle.
Yeah, to me, that's the interesting part for us, because right, if we're just tele-driving and sending commands and trying to do it real time, what do we have except for a RC car with a really slow radio? I mean, come on, this is DPRG. We have autonomous stuff. We give things guidance, right? We say generally, go over there and let it figure it out.
Look, the military flies vehicles on the other side of the planet. I wonder what kind of latency they have.
We make things smarter so they'll get smart enough and get up and kill us. That's awesome.
You know, what is it? Say the other side of the planet is 12,000 miles, 13,000 miles, right? And that is, if I remember right, is something like 1/8 of a second. So round trip is 1/4 of a second. Rough order. Because when we did, I used to know this because of the laser rangefinder that I did in the 80s.
Yeah, but remember, it's got to go through a satellite.
Well, and this is the funny part, because we did this VoIP phone at a startup I worked at called TerraStar, and launched a geostationary satellite. So it's 22,000 miles up, and it was like 1/8 of a second to French Guiana for the base station, another 1/4 of a second up to the bird, back down. So it was like a 1/2 a second round trip. If all you had to do was go up and back, like 1/4 of a second or 1/2 a second, something like that. And the funny part is that this was for a VoIP phone. and we were doing a 2 kilobit VoIP client across the satellite connection, routed up to the sky and back. So if I would sit on that phone here in my hand calling a landline here, it would have to go down up to the satellite and come back. So speed of light, it should only have been like a quarter of a second or a half of a second, right? But they had screwed up some jitter buffer or something somewhere in the system. Nobody could ever find it. And the voice in one direction was 0.8 seconds, and the voice going in the other directions was 1.5 seconds. Well, I'm sorry, but electrons, the speed of light only account for like a quarter of a second or a half a second. So the rest of it came from somebody's software somewhere sitting around in the server going, maybe I'll go over there sooner or later.
Packet was
Speed of light ain't what it used to be.
No. Okay, well, that's my update. I'm going to stop rambling now. And
all right, so I think the takeaway, as I heard it, Carl, is some of that MQTT stuff, all that stuff looks good. Just got to get the authentication figured out. Video stuff, the video stuff that they're showing, at least with that particular example, not so useful.
yeah, you're right. It's a science fair thing, not something we'd want to rely on because it can't rely on it. So maybe I'm sure there's other solutions out there, but I mean, what was nice is it wasn't too long to go through that. And actually, there's another part I didn't mention. That's the AWS Amplify. I pointed at it, AWS Amplify, and that's their kind of web app hosting service. So that thing I showed you, I was clicking the button and moving the robot around. That's basically a web server, and they wrote that app, and it's called Vue, which is like a JavaScript based framework for making web pages. But that could be, there's some interesting things if we wanted to go with AWS, where I'm sure it would more than handle our needs that we've been talking about on the free tier indefinitely. And there's a handful of services like that we could use. I even found there's a GitHub repo, somebody's cataloged them. These like serverless backends on the cheap, where you can like do this at the free level, that at the free level, that at the free level. So you can cobble together pretty complicated systems just in the free levels.
But the whole free thing, it's only for a year, right? I mean, they give you certain amount of compute time for a year. Other things are completely free for a year, but once a year is over, I mean, that's done, right?
It varies by platform, and even whether it's AWS or Harold could correct me, Azure or Google Firebase, there's a bunch of them that are free indefinitely if you stay within the bounds.
Yeah, on the Azure thing, there's probably 28, 30 services out there that are free indefinitely, and depending upon the like cognitive stuff and that kind of stuff, or like Azure functions in general, the first 500,000 activations of a function on Azure per month are free. So depending on what you're doing, it's always free for you.
Per month, right? So again, if we keep the internet, if we don't try and do this 20 hertz update loop from the browser to the robot, if we just like send events whenever you say you want to move, and then that's when you send the message. I mean, we'll be lucky if all of us were online at a meeting and we reached 1,000 in a month, right? So.
Again, it's just, it really is dependent upon the service. You need to just look and see. And I'll put a caveat on that. That is generally for proof of concept, not for production, but people use it in production because that's all they're required. You know?
Yeah, in theory, because they want you to pay for it eventually, but.
Absolutely.
Have you ever seen them shut down a hobby service like that? No.
I've never heard of it. It doesn't mean they had, but I don't believe they have. I don't believe they will. I mean, especially when they give you, like a lot of times, they will give you per second billing sometimes, or per minute billing, where a lot of other people will a lot of people will, at the time they were touting that, you know, if you used a second, you used an hour, kind of stuff. And they hopefully more people have gone to the per second or per minute billing on all this stuff anyway, on how things are working.
Yeah. Cool. Okay, well, I'm done. I'm going to shut up. I'm talking too long. Who's next? Who has some other stuff to show?
I got a quick robot fail I could show you.
Cool.
Okay. Let's see. Can you see that?
Yes.
Okay. Okay, this is another platform that I've done. It's a push mower that I converted, and I didn't realize it, but I used a set of old lawnmower wheels, ones in the back, and it seemed like it wasn't moving very fast, and I couldn't quite figure out why initially, but realized that the wheels were spinning in the tires. So let's see if I can get this to play.
Super glue.
The wheels in front were biting into the dirt and acting like brakes.
Come on. Can I play this damn thing?
Yeah, I think you're not supposed to put the WD-40 there, Ray, between the rubber and the wheel.
Yeah, yeah. Okay.
Ray, that's a classic problem with the RC race cars, and they super glue the wheels to the tires.
Yep. Well, for some reason I can't get this to play. Come on.
Yeah, while we're waiting there, my YouTube feed fed me a bunch of RC helicopter fail videos in the last couple of days, and you know, that big whirling 3 feet worth of death on the top of RC helicopters pretty damaging. Pretty whacked out videos.
Was it just property got hurt, Harold, or was it person hurt too?
Yeah, it's property. They didn't show any. They didn't show any. They show some close calls with some people, but none of them got hurt. It was more lines that people would try to. One of the craziest ones is the thing took off, tried to go inverted, and it got to doing one of these oscillating things, and finally the rotor clipped into the tail, and it was done. You know, and that sort of thing. Lots of stuff like that.
Well, I'm not certain why this isn't playing, but
Ray, maybe put that cursor in the center, that play button may show up. The mini view, you had a play button.
Oh, here?
Oh, there, yeah. Cool.
I have a joystick wired in. This is a Laura 32 U4 board. It's not one of the ESP boards. This one is a transmitter. It's got a small LiPo battery hooked up to it, a white battery. This one is actually running off the riding lawnmower battery, almost 12 volts. That's the LoRa receiver here, the antenna. That has a RoboClaw. I think that one's 30 amp. And plug it in. Hopefully it's not going to take off here.
Ray, is that differential drive?
Yeah, there's 2 motors there, if you can see them. One for each wheel. and it's just casters in the front. And this is where the wheels are starting to slip in the hub. So I do have another set of wheels that are much newer, and hopefully the tires are still stuck to the wheels.
Do you have the blade spinning at this point, or is it just the
No,
wheels?
it's just, yeah. Yeah, there it is. I don't know if you can see that in enough detail, but anyway.
Yeah, that's progress.
Yes, guess I need a new set of wheels or buy a couple bottles of super glue and load it up, you know. So
Nice. So that thing's getting close. What's next after the wheels on that one, Ray?
I've had a GPS RTK set up for several months now, and I'd like to get with Kareem and find out what he's done. And I think he's looked at, I don't know what it is. I want to say it's Southern Engineering lawn mowing or something like that, but that doesn't sound quite right. I think he got a lot of, information out of this guy who is set up similar to what Ross Melbourne did with the striping, like you select an area and then you segment it up into, multiple waypoints, or kind of as we would mow it, you push it down one row, turn 180 degrees and push it down the next row. That's, I think, how Kareem got the idea to do the robot that, writes numbers with lights that he showed us a couple times. So that's the next thing I'd like to do.
Ray, you mentioned adding RTK, and all I could think about was, whatever happened to a proper mower like this? Where are you going to put GPS RTK on that, right?
Yeah.
I mean, these are fine. There's nothing wrong with these mowers.
My wife actually wanted one of those, and I said, you're not going to be able to get it through our lawn. Our lawn has like little trees and, hard, scraggly, little thorny bushes, and, you probably couldn't. I don't know.
I don't know how many years I used this to mow in my parents' yard. It was okay, anyhow.
Well,
It's a lot of work.
It's a lot of work. Yeah.
Back in ancient
I will say that I think ultimately what we need to do is get the recombinant DNA guys to develop for us grass that only grows to a fixed height.
Oh,
there you go.
Wouldn't need to mow it.
Yep. Back in ancient history, I had one of the houses I had had so little yard that I got rid of my power mower and got one of those push mowers because it was more trouble firing up the power motor than just getting out the push mower and doing it.
Nice.
Ray, I wonder if it's like a sculpture, right? You can change, you can etch some parts away, and if you can lift the height, it's like three-dimensional.
Oh yeah.
Yeah.
Well, I have 14 acres, and before the election, I was gonna write some derogatory comment about Trump in 14 acres, but never got around to it. So. Dump Trump.
Well, I only brought up the self-mowing grass only half in jest because some years ago, this guy came around and gave a presentation. He's a traffic engineer, and he was showing an intelligent intersection. Whereas the cars approach the intersection, basically the traffic computer takes over, and all it can do is slow the car down a little bit. few miles an hour. That's the only control it had. But with that kind of control, you have all these cars slipping in between each other in the intersection. So if you make something like that happen, of course, everybody's got to have a transponder in their car and so forth. So we're talking down the road a little bit. But all the money we spend on these huge steel and concrete intersections, those will be white elephants, boondoggles. Nobody will need them anymore. All you need is a smart intersection. And all the money we spend on these huge overpasses, and look at Dallas. All that becomes obsolete. Probably art collectors will buy them.
I wish that were true, but I know too many people that will get up and go, hey, that's slowing me down. If I tweak this a little bit, I'll get through this intersection faster than the next person. And they're going to start turning their knob up to 11, and then we got the same problem all again. I hate to be negative like that. I truly do. I think I'm being more realist than negative, because I really would like a system that you have.
We don't really have a problem with air traffic.
No, we don't.
There's ways to keep people from cheating.
You're right.
Resistance is futile. You must comply.
No, I'm hoping all this happens long after I'm dead, because I actually enjoy driving. I'm sure I've told you guys this before, but when I started flying helicopters, it was because I wanted to build what you can now go out and buy off the shelf as a drone. And I thought, well, the first thing I need is the skill set to fly helicopters, so I'll know how to develop. But what I found, I was seduced. Flying the helicopter was so much fun, I had no interest in turning that over to a computer. And that was the end of that, My adventure led me astray.
I will tell you, as far as the driving goes, today on most modern cars, we're all riding behind the wheels. I used to own the last year they were here, made them in the United States, a 1980 MGB convertible. I will tell you, that's not the most powerful car in the world. It is low to the ground, and not as low as they were at one time because of some height restrictions and safety regulations. But even with that 64 horse, 65 horse motor in the thing, you get it going pretty quick, but you're driving that car. You're not sitting behind the wheel. Because I will tell you right now, going down the road at 70 miles an hour in that car, and you think about being in the other lane, and now you unconsciously may move your hands just a little bit. You're in the lane about the time you're thinking about you may want to be in that lane, because it's so responsive. And most cars today, I can do this number and not change lanes sometimes, or at least it feels that way. I'm putting on my makeup, driving with a knee, and eating a corn dog at the same time. I think you can't do that in this car. You can't do it. You'll end up in a ditch.
You can, however, hang your hand out the window and drag your knuckles on the pavement.
You can do that too. You can do that. You can
dropping your nails.
Yeah.
Back in the ancient history, I had a MGTD.
Oh wow! Awesome.
That was a fun car.
Dave, was that like in the 50s or 60s?
That was 59. But it was one that a friend had that I got for $500.
Wow.
That's awesome, man.
Not only that, I didn't have the $500 at the time, and because I just came off of having a holiday and then going to work. And he said, oh, well, just send it to me when you get it. And he signed it over to me.
That is awesome.
Yeah, Dave, your Miata is the standard, right?
Yeah. No,
Yeah.
no, it's automatic because.
Oh, it is. Okay.
Yeah.
Yeah.
But when I checked it out, I was buying a new one, and the only thing they had on the floor at the time was a stick shift. So I tried driving that around, and I went back to the guy and I said, boy, I sure like that, but I think for Dallas traffic, I need an automatic. And he said, well, get one of each.
Well, there you go. I will tell you, the designer of that Miata is the same person that designed the MG Bs, as well as I think some of the MGAs. Same designer, same basic car designer. Or same
Well, I
basic.
know I drive my Miata around and it does not respond as fast as the MG used to, but it's still a lot of fun.
Yeah, it's a lot of fun. But you get what I'm saying. The people that have driven these little cars, it doesn't. I mean, it's rack and pinion. There's no power steering. It's just a direct thing, and you're just thinking about it and twitch it just a little bit, and you're off to the whichever side of the road you want to go. You know.
There's no power steering, and the brakes don't work very well, and the suspension is very wooded.
Oh, yeah, you don't.
Not only that, but the TD had a wooden frame.
Oh my God.
You know, back in the day, they thought that the design goal was to make a flexible chassis. That's how those were designed. So moving forward into the 60s and 70s, the engineers decided what you want to do is make the chassis as rigid as possible so that the suspension handles all of the woodiness.
Yeah.
But if you drive one of those, and I've got a friend that has one, he said they drive it. Boy, go over railroad tracks or something, you can really feel it. That whole car, whole chassis.
Yeah, it's funny. You get to looking at the design decisions of stuff. So I had this car got worked on before, and I happened to work on the car a little bit before I got it. And what would happen was, as soon as you turned on the ignition, the starter would engage and try to start and never stop trying to start. So after we looked at the schematics a little bit and all that kind of stuff, literally, and it was a points-based setup thing. So, but literally everything that was driving the ignition coil and all that kind of stuff was being directed through that key switch, the ignition, and that key switch is shorted out. So all that stuff fired all at the same time whenever you turned it on there. It's crazy stuff. And who thought that was a good idea? A couple of solenoids later and a couple of other things and the problem was solved, right? But it was crazy. Like, I don't need all of my ignition parts going through that key. How about you just leave it right there next to the thing where it is?
Dave's trying to measure timing now.
Guys, I think we've wandered far enough afield that I'm gonna bid good night.
All righty. We'll see you later, Dave. If no one else has anything else, I think we're all petering out. So
I think that sounds like a plan.
all righty.
I've
Gentlemen.
got a quick
John,
suggestion for my son.
Oh, okay. Jen, you got to speak up.
Yeah, I mean,
Oh, shut up.
it's really advertisement for my older son. He bought some MOSFET. I think it's for high-speed power switching. But I'll post the information here. He bought thousands of those.
Thousands of MOSFETs.
I don't really know what it is, but maybe I'll share a screen. Yeah, I guess his idea is somehow, yeah, he can share it with someone else. Am I sharing?
Yeah,
Yeah.
we
Okay.
see a
Do you guys
Google
see a
Doc.
document?
It's awfully small.
Oh, is this too small?
Yeah.
If you
You
can make
guys
it
see the
bigger.
document, right?
And the link you posted doesn't have rights, I think. At least I couldn't get in, but
Well, okay. So basically,
yeah.
this is the thing that he bought. Oops. So this is the thing, and this is the instruction manual here. But I don't know, like, do you think robotic guys are interested in these things?
That's a pretty pretty good switch. I mean, 180 amps and 75 volts. That's a lot of power.
Ray, I think
Well,
they're all
I
yours for your.
Yeah, and milliohms.
Yeah, 3.6 milliohms. Although some of the RDSs now, a lot of them are in that range. They're extremely low.
So if we wanted to mass produce H bridges or something like that,
Yeah, well, I'm gonna. I just want to maybe I email to the list with this information.
Yeah, yeah,
So
sure. You
his
never know.
idea is if someone's interested, he can mail it, or you guys can come by and pick up, or someone can come by and pick up. But yeah, we have a big box of this at home. I think at one point maybe it goes into the makerspace. That would be one place to see.
Yeah.
I've got a friend of mine. You know, I do got some friends that Magic and used to own Magic stores and do a bunch of these things and about I think it's probably about 25 years ago now. A lady named Cindy, she needed to buy a magical gizmo. We call them thumb tips. You may be aware of them, maybe not, but they're little plastic thumb-looking things. And she thought she was buying a gross because she marked on the box to buy a gross. It turned out there was a gross in the individual box, so 144 of them, and she bought a gross of those. So she still has those, and it says, if you want them, I got some more. We don't have the store anymore, but if you ever need one, come talk to me.
Yeah, I know it's always a liability when you have too many.
Yeah, so you may be having these MOSFETs for quite some time, John. I'm just just say it.
Yeah, I told him I'm like, okay, you can
those
get
look
it.
like some, that you might use in a CNC controller or something like that.
Yeah, we use them in the 3D printer world to control the voltage and the high current going to heat beds and that sort of stuff, because sometimes they can draw a lot of current. But most heat beds are 12 or 24 volts, and if you want to throw, you get them up to 60 degrees C or sometimes 110 degrees C, you're throwing some wattage at those things, and a lot of these boards aren't built to be able to switch that much current without getting brown at the very least. And so we're throwing MOSFETs on those to make them happy.
Yeah.
Yeah, I mean, on my side, it's really I'm too busy for the past week, so didn't really get much robotic thing done. So next step is to solder some, again, my wireless serial connection. I mean, I'm really software guy, and this hardware is really like something I'm really concerned about. So
I have a kind of a question. Has anybody played with something called Segger, Segger? It's a thing that runs on top of Eclipse. Anybody had any playing with that at all?
I've heard the name, but I haven't played with it. So
yeah, you probably saw it the other night, Carl, if you're watching me on my Twitch any at all. That's the basic build stuff for this new context, which is that Nordic NRF stuff that's going on. And I just, I sent a note out to the discussion list and asked them, hey, who can do this? And is there any documentation for the layout stuff? And the response I got back was, we have a webinar coming on the 18th that should tell us most of this. I'm like, if the webinar is great, but you would think they would have documentation already that I could start reading now, but I don't suspect the webinar shows up and miraculously this documentation is going to spring to life. I somehow got a feeling that the contestants of this thing will be writing some of this documentation. And that's just kind of what they do with these Hackster IO things, is generate interest, generate web presence on it, with a bunch of people doing a bunch of projects with the thing, and then getting some documentation and other junk out of it.
Then they put you to work.
They put you to work. But if you win, there's a couple people who don't win. Top prize is $2,000. Hey. But that's I don't know that I'd win the top prize, but I want to I'm going to try. If I'm in the money, that'd be good, but who knows? Regardless, so I learned something. I got some cool hardware, and I got a capacitive touch Arduino shield screen out of the thing. So that's $50 right there that I get to play with.
That always struck me the same way about those DARPA grand challenges, that basically you get all these different teams working on it, and it doesn't cost them a dime, and you put up your own money, and then you only have to invest in the one that worked. And
yeah.
You know, so I sure understand why they want to do it.
Oh yeah, free development.
Yep, that's exactly what's going on there.
All right, guys. Well, let's have fun next few nights next week. We'll catch up next Tuesday.
Okay. Take care.
Take care. Bye.
Here, guys.
Bye, guys.
Bye bye.